I have had so many of you asking me to do a video on coordinate geometry that I couldn't resist doing one before the end of the year. So this is that video. Then, when I was thinking about all the different topics that come up in coordinate geometry, from the very basics to the crazy advanced stuff, I was like, there is no way I can fit that into one video without people just completely giving up halfway through. So I thought this video would cover 80% of what you need to know. It would also cover the most likely topics to come up in the exam, and I'm going to save the more advanced topics for another video for those dedicated few. We're going to cover slopes, quadrants, equations of a line, parallel lines, perpendicular lines, hopefully all in one video, but we will see how we go. I might be going fairly quickly, so if you need to, you can pause the video, rewind and rewatch. But if I didn't go relatively quickly, this video would be like an hour. Let's start with quadrants. And using the diagram that you can see on screen, you can see that the quadrants start in the top right, quadrant 1, and work around anti-clockwise, quadrants 2, 3, and 4 beneath quadrant 1. Many students, and I used to believe this before I learned, thought that quadrant 4 was in the bottom left, in the negative axis, but that's not actually true. It goes quadrant 1 in the top right, and then anti-clockwise quadrant 2, 3, and 4. I'm surprised by how many students don't actually know that, so that's definitely useful knowledge if you didn't. Next, you need to know that the y-axis is the vertical line and the x-axis is the horizontal line. I'm sure many of you knew that already. Did you also know that the origin is that point right in the middle, 0, 0, where the x-axis and y-axis meet? You probably did know that. So I'm going to move on to the next topic, which is finding the equation of a line. You might have heard of this famous equation, y equals mx plus b, that you can see on screen. But what do the letters mean? Specifically the m and the b. The m is the slope of the line. That's the gradient, some people know it as. And the b is the y-intercept of the line, where it crosses the y-axis. Now, many people know that, but they're actually a bit foggy on how to calculate the m and how to calculate the b. And if I gave them two coordinates, they wouldn't really be able to give me the equation of the line in that form, y equals mx plus b. So that is what our first question is about. And I want to add in at this point that all the questions we're going to do today are phrased exactly as they might be in the real GRE or GMAT exams. They're tested in a very similar way. In fact, two of the questions I'm going to use are from the actual official ETS math review. Here is the first official question. The line you can see on screen goes through the points -2, -3, and 4, 1.5. And I'm going to ask you, what is the equation of that line in the form y equals mx plus b? If you think you know how to do it already, you can have a go. And for everyone else, I'm going to teach you how to find that m and how to find that b. To find the slope, I'm first going to get you to think of it as the rise over the run. And later, I'm going to give you the formula. So you have two approaches to think about with the slope. First, the rise over run approach. That's where you consider, by picking one of the coordinates, how far has it risen in the vertical or y direction to get to the next coordinate, and how far has it run in the x coordinate direction, the horizontal direction. You find out how much it's risen and then divide that by how much it's run, and then you would have your slope. We're going to use that approach first with these coordinates, and then afterwards we're going to use the formulaic approach. Before we get started, remember that the coordinates on the left are the x coordinates, the horizontal coordinates, and the numbers on the right are the y coordinates, the vertical coordinates. So let's take our coordinate on the left, -2, -3. How far has that risen to reach the coordinate on the right, 4, 1.5? For this, we need to look at the y coordinates. So we've gone from -3 to 1.5. That's a jump of 4.5. To get from -3 to positive 1.5, we have to rise by 4.5. So that's our rise on the top of the fraction. Of course, by the way, if we'd have gone down, we'd have written that as a negative number. But no, we've gone up by 4.5. Now, can you calculate our run? How far have we gone across in the horizontal or x direction between those two coordinates. You always must consider the same set of coordinates. You must start with one coordinate and go to the other one, not mix them up, not start with the other coordinate and go back to the first one. We're going to start with that coordinate on the left and always be focused on getting to the coordinate on the right. What's the run? Well, we've gone from -2 to +4. So that is a run, I think, of 6. From -2 x coordinate to an x coordinate of 4. From -2 to 4, that's 6. So our run is 6. Our rise was 4.5 and our run is 6. So we have the fraction, the slope, 4.5 over 6, which of course we can double to get rid of the decimals, 9 over 12, and we can simplify that down to 3 over 4. So 3/4 is the slope of that line. Now just quickly, for those of you who love formulas, we have the formula y2 minus y1 over x2 minus x1 to calculate the rise over the run. Essentially, it's a formula used to calculate the same thing we just worked out. You label one set of coordinates, x1, y1, let's say that's the -2, -3, and you label the other set of coordinates, x2, y2. We can call that the coordinate on the right, 4, 1.5. Then we just churn it into the formula and out will pop the slope. So no kind of visualizing rise over run, you just chuck it into the formula and work it out. This is a better approach for those who are very confident with negatives, because a lot of negatives and double negatives tend to come up with this situation. As we can see here, the y2 minus y1 would be 1.5 minus -3. And the two negatives cancel out to give 1.5 plus 3, which is 4.5. And again, with the run, or the bottom side, that's x2 minus x1, that would be 4 minus -2. And the two negatives cancel out to give us 6. If you're confident with negatives, you can use that formulaic approach. If not, you can use the visualization approach. How far do we have to rise? How far do we have to run? Either way, we have now worked out our slope, our m. It's 3/4. So we can now insert that into our magical equation. And this is a key step that many students miss out. They have the slope and they're like, what do I do to work out the plus b? We're going to insert that slope, insert that m into that equation, y equals mx plus b. We would now have y equals 3/4 x plus b. We're at the halfway stage. We've worked out the m, but we haven't worked out the b. That halfway stage is important. You've got to write down that equation. Y equals 3/4 x plus b. How do we work out the y-intercept if we don't have a visual graph to just observe where it is? This is the key step, and this is why we wrote out the equation. We need to insert one of the points into our equation. Many of you might think that the solution is to put x equals 0 into that equation, but you'll find out that that will just tell you y equals b or something. It won't actually tell you what the plus b is. Instead, we have to put both sets of one of the coordinates into the equation to work it out. It doesn't actually matter which coordinate you pick, just pick one of them and insert both numbers into the equation. Let's do that with the -2 and -3. That's one of the coordinates on the line, and let's insert that into the equation. Remember, our equation currently is y equals 3/4 x plus b. With the coordinate -2, -3, our x is going to be replaced with a -2, and our y is going to be replaced with a -3. So we now should have, you can pause the video and do this yourself, or I can go through it, -3 equals 3/4 times -2 plus b. And that's how we find the plus b. Working that out, you should have -3 equals -6 over 4 plus b. -6 over 4 becomes -3 over 2, or -1.5 plus b. So we have -3 equals -1.5 plus b. Adding 1.5 to both sides, we would have -1.5 left over on the one side equals b. So that's our b, that's our y-intercept, -1.5 or -3 over 2. Of course, you could tell that from the graph just by looking at it, that it crosses over the y-axis at minus 1.5, but you now have the perfect method for working it out, even if they don't give it to you visually, which is most likely what they're going to do. They're not going to give you the graph, so you have to work out the plus b. How do you work out the plus b? You insert one of the coordinates into the equation after having worked out the slope. Can you remember that? We now have our full equation, the full equation of that line. Y equals 3/4 x minus 1.5, or minus 3/2, same thing. I've seen some students make the mistake of writing something like y equals 3/4 times minus 2 plus whatever. But no, we only use one of those coordinates just to work out the m and just to work out the plus b. We don't actually use those coordinates in the final equation. The final equation just simply has the m and the b written with x and y untouched. Y equals 3/4 x minus 1.5. That is the equation of the line. At the end, we're going to do an example that brings this all together for a final time. So don't worry if you think you need a bit more practice, but for now, I'm going to move on to our next topic, which is writing out that equation in the form ax plus by plus c equals 0, which is how you'll sometimes see it. Believe it or not, the line we just worked out is equal to 4y minus 3x plus 6 equals 0. How so? Well, we've simply moved it all to one side, keeping a 0 on the right, and then multiplied everything by 4 to get rid of both fractions. Why do we do this? Simply because for some people that's an easier way to write it, and more specifically, sometimes the GMAT or GRE would prefer you write the equation like this. So it's good to know what to do. You've done the hard work, you've done the coordinate geometry, this is just basic algebra. Move everything to one side and always multiply to get rid of fractions. So that equation that we worked out, y equals 3/4 x minus 1.5, is identical to 4y minus 3x plus 6 equals 0. Now, I've got one final topic I want to cover before I move on to parallel and perpendicular lines, which is the last topic of this video. And that is, how do you find the x-intercept? We've talked about finding the y-intercept of a line by putting the coordinates in and then working out the plus b. But how do you find the x-intercept? So the x-intercept is where the line crosses the x-axis. And where the line crosses the x-axis, it will have a y-coordinate of 0. It won't be off the ground at all. The y, the vertical, will be 0. And that's the secret. You replace y with 0, and that will give you your x-coordinate. That will give you your x-intercept. Let's quickly do that with this line that we have here. 4y minus 3x plus 6 equals 0. Can you quickly tell me the x-intercept? And I don't want a smart answer by looking at the graph. I want you to tell me if we had no graph there. Hopefully you replace the y with a 0 to find the x-intercept, and you got minus 3x plus 6 equals 0. Adding 3x to both sides, we have 6 equals 3x, and then divide by 3, 2 equals x, or x equals 2. So that's the x-intercept, which we can confirm by looking at the graph is indeed where the line crosses the x-axis at x equals 2, or the coordinate would be called 2, 0. You guys are so lucky today because I'm going to be covering yet another couple of topics in this same video. Please hit the like and leave a comment if you've made it this far. The topic is parallel and perpendicular lines, and the diagram I have on screen just shows you what that means visually. So parallel lines have the same slope, the same gradient, and they will never meet. No matter how long they carry on, they will never touch each other. Those are parallel lines. Perpendicular lines, on the other hand, cross over exactly 90 degrees. But how will that be tested in the GRE and the GMAT? The parallel lines bit is a bit easier. You can tell if the equations of two different lines are parallel by checking if they have the same slope. If the m's are the same, then they have the same slope and therefore are parallel. You might need to rearrange the equations to put them in the form y equals mx plus b to see what the m's are, but if you find out that the m's are the same, then you have parallel lines. But how can we tell if the lines are perpendicular? This is the funky bit that some people struggle to remember. Perpendicular lines have slopes that are the negative reciprocal of one another. What that means is if my line has a slope of 5 and your line is perpendicular, the slope of your line will be the negative of that, so that's negative 5, but also reciprocal. Reciprocal just means flipping the fraction. Now you might say 5 isn't a fraction, but 5 is 5 over 1. So if we do the reciprocal of that, we get 1 over 5. Bringing those two things together, if my slope is 5, your slope as a perpendicular line would be negative 1 over 5. If my slope is a third, your slope is the negative reciprocal of that. The reciprocal of a third is 3 over 1, which is 3, and the negative makes it negative 3. And that's how you deal with perpendicular slopes. I'm going to bring that together in the following GRE style question. Which of the following lines are either parallel or perpendicular to the line with the equation 4y minus 3x plus 6 equals 0? Before you get started, you might have realized that you're going to have to rearrange each of these equations, if they're not already in that form, into the form y equals mx plus b. Once you've done that, look at the m's, and if they're the same, it means they're parallel to our original line, and if they're the negative reciprocal, they are perpendicular. So pause the video, have a go yourself. If you can't do it, I'm now going to explain. Many of you might have been thinking, well, what is the slope of that line 4y minus 3x plus 6 equals 0? Well, we did do this earlier, but what you're going to have to do is rearrange it back into the form it was before, with just a single y equals blah 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 x plus blah blah blah. So rearranging that, we push the minus 3x and the plus 6 to the other side. So we have 4y equals 3x minus 6, and then we divide by 4. So y equals 3/4 x minus 1.5, back to where we were before, with our slope being 3/4. Your job is to rearrange all the others in that same form and look at the m's, look at the numbers next to x. Those are our slopes. If they're the same as 3/4, that means we've found a parallel line. If they're the negative reciprocal, we've found a perpendicular line. Just quickly, what's the negative reciprocal of 3/4? It would be 4 over 3 with a minus, so minus 4 over 3. That's what you're looking out for to find a perpendicular line. I'm not going to go through all of them, but you should have found that the second line was perpendicular to our original line, the third line was parallel to it, and the fourth line was perpendicular. And the first and fifth were neither parallel nor perpendicular. I said that there would be a question at the end that brings it all together, and here it is. In fact, it's a multi-part question testing many different things, so I just thought it would be worth doing to cover all the different knowledge you might need to know for at least 80% of the questions that you'll see on coordinate geometry in the GMAT and GRE. You can see the question on screen where we have a line and then a vertical line going down from one coordinate. And the first question, question A, is to work out the coordinates of point Q, which is vertically beneath point P. It's a nice little warm-up to get us started. As with all of these questions, feel free to pause the video, work them out yourself first, or you can just listen to my explanation. So point Q is vertically beneath point P, which means it's going to have the same x coordinate. The horizontal direction of both coordinates is the same. So the x coordinate is going to be -2, and because it's on the x-axis, the y-coordinate is 0. That's our first question answered. The coordinates of point Q are -2, 0. For B, they want the length of each of the line segments. Now 2 of those are easy, and the third one involves a topic I did in an earlier video that I would strongly recommend you check out if you don't know about it. So the length of the line segment PQ is simply 6. It doesn't move at all horizontally, it just goes up 6. So that's a length of 6. The length across from Q to R goes from -2 up to 5, and that's a length of 7. How to work out the line between P and R? Well, I've done another video on the distance between two coordinates, so I strongly recommend you check that out. But for now, briefly, we're just going to do Pythagoras. We're just going to do 6 squared plus 7 squared and then square root the answer. 6 squared is 36, 7 squared is 49. Adding those two up, I believe we have 85, and the square root of that you can do on a calculator, but you could just write root 85, or in the GRE, if they wanted a decimal, you could type 85 and then press square root, and it should be something like 9.1 or 9.2. Question C is easier. The perimeter, you just add up 6, 7 and the 9.2, and that's your perimeter, that's fine. Likewise, the area shouldn't cause you any problems. That's just the base of 7 times the height of 6, divide by 2. 7 times 6 divided by 2 is, I believe, 21. It's the part E that I want to cover, because that covers what we've done in the earlier part of this video. What is the slope, y-intercept, and the equation of the line going between P and R? Let's take each of those in turn. For the slope, I'm going to use the rise over run approach. How far have we risen to go from -2, 6 to 5, 0? Focusing on those y coordinates of 6 and 0. Well, we have fallen actually by 6. We haven't risen by 6. To go from the coordinate on the left to the coordinate on the right, we have actually fallen by 6. So our rise is -6. What's our run to get from -2 all the way to 5? Our run, if we look at the x coordinates, is 7, because we've gone in the right by 7. So our rise over run is -6 over 7. That is our slope. Do you remember how to find the y-intercept of the equation of a line if it's not obvious visually from the graph? Massive brownie points to you if you said you write out the y equals mx plus b and then insert one of the coordinates. The equation so far is y equals -6 over 7x plus b, and we don't know that plus b. And we're going to work it out by replacing the x and the y with one of the coordinates. Let's do 5 and 0, the coordinate on the right. It doesn't matter which coordinate we use, but that one looks easier. Replacing the x with a 5 and the y with a 0, we have 0 equals -6 over 7 times 5 plus b. -6 over 7 times 5 is -30 over 7 plus b, and pushing that -30 over 7 to the other side would give us +30 over 7 equals b. So we've found our y-intercept, our plus b, by inserting one of the coordinates into the equation. We now have the full equation of the line. Y equals -6 over 7x plus 30 over 7. Just for a massive brownie point, just from me, they're not asking us to do this, but imagine if they asked us to write the equation as ax plus by plus c equals 0 without any fractions. We'd times everything by 7 to remove the fractions, giving us 7y equals -6x plus 30, and then move everything to one side, the left-hand side. So we'd have 7y plus 6x minus 30 equals 0. It's the same equation written in a different form. Mind blown. We have covered so many topics in one video. I really hope you could keep up. And if not, of course, just pause, rewind, rewatch, because I've covered a lot of content in one video. In fact, I've covered what I would say is 80% of what you need to know for the GRE and GMAT in terms of coordinate geometry, with just a few advanced topics like parabolas, transformations, and equations of circles that I'll do in a future video. I just really wanted to help those people who've got the exam coming up and they asked me to do a video on coordinate geometry. I really hope this has helped. Please leave a like, comment if it has. See you very soon.